You guys okay? All right, this is truly, there is no lie in what I'm about to say. What we're gonna start today is the last topic of the AP Calculus AB curriculum. It truly, we're done.
Whoa.
Jasmine, no lie. We are done. This is it. There's no like loophole here. We're done. With a month still to study for the AP exam together. We are in a very, very good place. This unit so far has been a good one. We've done area, we've done volume. Specifically though, I need to clarify, we've done volume of revolution. I say revolve, right? Volume of revolution, you guys are thinking like spinning things, right? Here's the thing, when you talk about a volume of revolution, you always get things that look like the toilet paper roll, right? Or a vase, things that are round on the outsides. Now, solid all the time? Do you always get a solid object?
No.
No, sometimes you're gonna get a hollow object. And if you get a hollow object, that's when we need to start thinking about, what were we calling these? The washer, right? And if you know that you have a hollow object, then that tells you what your setup's gonna be, okay? Okay, don't make me throw my toilet paper again. Right, so everything we've done has been a volume of revolution. You could make a cup through a volume of revolution. Okay, you could do that. You can make the toilet paper. Could we make Homer Simpson?
Yes.
Clearly we can make Homer Simpson. But here's the problem. Like, what's here is not actually truly a volume of revolution, because if it was a volume of revolution, you'd go all the way around. Right? These aren't discs. They're not like full, what are they?
Rectangle.
Did you see rectangles here? Oh my gosh.
Half circle.
They're half circles. I think at some point in my life, somebody gave me a better word for half circle.
Semicircle.
Not cylinder. Not half circle. We called it a
0.5 circle.
semicircle. It's a half of a circle. Here, pass it around. There are other objects that we're going to be studying. Like, for example, the Titanic that somebody made once for me.
Whoa.
Okay, it's nice, yes. Okay, not a volume of revolution. Not something you make by spinning. Look at the slices. What are they?
Triangle.
Be specific. Half a diamond. Oh my God! All these geometry words that we make up. Yes, they are triangles, but these might be specific triangles.
Right.
I don't see right triangles here.
Equilateral.
Okay, these are like maybe equilateral triangles. Maybe there are some, you're not even looking, you're making up words. Here you go. Okay, you could look at an object, I don't know, anybody who has like a Superman fixation.
He died though.
Okay, moving on. Spoilers. Okay, this object also not volume of revolution. It is a three-dimensional object, but the slices, the cross sections are
Square. Rectangle.
four-sided figures, right? I think their intention was they were going for squares. Okay, let me start these back here. This is where we're going to focus all the work this week. Everything we're going to do is going to be slices that aren't circles. They're not washers. They could be rectangles. They could be triangles. They could be semicircles. They could be all the things. Ron Beer, can you go to the back and drive the geometry sketch pad? Okay. Okay, you're good here. And duplicate.
Where's what from?
And I thought.
From a binder.
In. And.
And he doesn't die. He doesn't want. No, he doesn't.
Dark side kills me.
He does, but then the dirt. No, he's not.
You don't even know if he comes forward.
In the end, they show like a little
The
thing.
dirt
Yeah.
literally goes up.
Aha! Perfect.
They would never.
Why would they put it? God.
All right, let me pull everybody back together. Sorry about the awkward transition
yeah.
there. Okay. So, here's the new thing. There's nothing I need you to worry about with notes right now. I just want you to take it in and enjoy and be ready to ask any and all of the questions that you got. Anthony, you doing okay there? All right. So we've got some new ideas. Rather than doing volumes of revolution, the new idea is going to be, they're called cross sections. What's it called?
Cross section.
Cross sections. I want to think about
Oh my god.
slices, right? Just like if I was slicing the Sunday ham, right? I'm going to take my knife and I'm going to slice up the Sunday ham. Here's how we're gonna build this object. So Rambir, only do the things I ask you to do. This circle over here we're gonna call the base. It's the bottom part. We're gonna build an object coming out of the board at you. If I was struggling last week to draw the volumes of revolution, trust me, I'm gonna die even trying to do this. But fortunately with Geometry Sketchpad, Rambir, I see you, hold on. This is the base. What I want to do is help you visualize slices coming out of the board. Here is your x-axis. Here is your y-axis. Rambir, I want you to drop y-axis flat. You're going to have to go up to the arrow. Drop y-axis flat. Okay. What happened is the base that was going this way, like vertical, just fell flat. So you've got your x-axis going this way, you've got your y-axis kind of going into the board, and this thing up here, if you had to give it a name, you might go with not x-axis, x-axis is already taken. The z-axis. Welcome to 3 dimensions. Mathematicians are very logical human beings. You have the x-axis which goes this way, the y-axis, just for your perspective, goes off at this diagonal, but imagine being able to go deep into the board. Z-axis pops up. Are we okay? All right, let's talk about the slices. What I want you to do is show chords. Okay, chords, you might remember from geometry, are line segments. Line segments that go from one side of the circle over to the other one. Nothing special about a chord, that's what it is. I want you to click on C4 squares. Everybody sees 4 squares?
Yeah.
Okay. The base is the circle. The squares are going from one side of the circle all the way to the other side of the circle. Right, that's going to be your chord. And then you're going to go up, whatever the amount is. You're going to go over whatever the amount is. You're going to come back down, whatever the amount is, to make your square. Big picture, everybody okay? Jasmine, you're right there? Okay. We've got squares up front, we've got squares in the middle, we've got squares in the back. Rambir, what's up?
How do you know what your height level is?
That is a great question. It has to do with the slice. What do you know about the slice?
Slices, bro.
What do you know about these slices? What are they?
Squares. A rectangle.
They're inside of the circle.
What are these slices? They are squares. So if I'm going to have a square, how far up I go is determined by how far across I go. If the distance from here across is 2 units, then my height has to be 2 units to keep the square. Everybody okay? All right. I want to make the 3-dimensional piece. So what you're going to do is we're going to sweep one square. Right? So we've got the square starting on this far end. As it gets closer to the y-axis, it has to get taller because it's going a greater distance. And then it shrinks as it gets closer to you. Okay? Let's go further. Create solid.
What?
It's a dome.
Oh my god.
That's live.
Whoa.
Okay. So a little more. Click show solid. It'll stop moving. Okay? This is the object that we're talking about. This is not a volume of revolution. I'm not spinning. I am taking an object and I'm slicing this object. I'm slicing the object, and each slice is what? What's the slice?
The same distance as it
What's the name for each slice?
is.
They are,
DY.
well, hold on. What's the name for the slice? Is it a circle?
Square.
They are squares. Where's the object that was the square slices? Jennifer, can you get that one? Okay. So Jennifer, can you show me, where would the base be? If you guys take a look at that, where's the base?
Oh, the Superman.
Right, the base is the bottom, but specifically, it's the thing that you're using to determine the square. So like, here's your base. Now, when you do slices, one of the things we're gonna have to talk about is, are you slicing, can you guys show me your x-axis? If I said make the slices parallel to the x-axis, what would that mean? Parallel to the x-axis, I'm going this way, right? This is parallel to the x-axis. If I want to go this way, perpendicular to the x-axis is a way to describe that. There's another way to describe this.
Parallel.
Parallel to the y-axis, right? So if I said make your slices perpendicular to the x-axis, show me what you do. Perpendicular to the x-axis. If I said make them perpendicular to the y-axis. Kimberly, you okay there? Okay. And if I said make them parallel to the y-axis. Okay, good. We get. What we're talking about is what way am I slicing? Am I slicing this way? Which way is this? It's the Jedi way, right? But it's the.
That's the y-axis.
Parallel
I'm
to the
slicing
y-axis.
this way.
Parallel to the y-axis.
Okay. All right. Good. So we've got our solid. All right. Show no, not that. Slide the square in the solid. So we've still got the wireframe, and I just want you to see, like, you've got the square slices all the way through. Big picture, everybody okay? All right. Our goal this week is to figure out how do you actually find the volume of these things. It's not volume by spinning, so not volume of revolution. It's volume a slightly different way. Ranveer, great job. Why don't you rejoin the crew? What I want you guys to do is just take 2 or 3 minutes and read through the notes on the first page. And then we'll get into like the real calculus.
We're happy days.
Oh, you can just read it to yourself, maybe. So page 1 and top of page 2, that takes 10 minutes. How many of you guys need a little more time to read? Okay. All right, what questions are out there? What questions are out there? David.
Is it only shapes that are going around a circle?
Okay, and that's similar to the question Juan you just asked. All the examples that are here, the base is a circle. The base does not have to be a circle. Could be any base whatsoever. The Superman symbol, for example, the base isn't a circle, right? The base is the Superman insignia, the Titanic, not a circle. Other questions that are out there? Everybody's good? Ron Bear,
Can you show me the difference on the second page?
can I show you the difference on the second page?
With
What do you
like
mean?
the X and Y? 'Cause like I see the picture and it's like the shading. I don't know if it's the shading, but I can't really tell the difference with whatever the slice of parallel to the X and Y. Like, where they're
Okay.
going.
Okay, that's, yeah, so the slices, you're slicing like, kind of like this way, if you can imagine slicing it this way. That's what they were trying to show with the darker image. Over here, you're slicing this way, so you would be parallel to the y-axis versus perpendicular to the y-axis. We're gonna get a lot of practice with drawing these. It's gonna make a lot more sense. Other questions that are out there? Everybody okay? All right, so let's just jump right on in. I want to do a model problem or two, then you guys are going to get some practice. All right, Mariah, can you read this first one?
The base of a solid is the region bounded by the graphs of y equals even negative x, y equals -1, x equals 0, and x equals 1. Each cross-section perpendicular to the x-axis is a square with one side in the xy plane. Determine the volume of the solid.
Okay, this is what the problem is going to look like and feel like. One of the things that they have to describe for you, what's the base? Where's the base? No. What's the base?
It's bounded by the graphs.
Bounded by the graph.
Right, the base is bounded by y equals e to the negative x. Do we know what that looks like?
Yes.
Should know what that looks like. Y equals e to the negative x. Can you guys draw that for me? It's been a while. E to the negative x. E to the negative x. Y equals e to the x increases from left to right. Y equals e to the negative x decreases. Okay. We've got y equals e to the negative x. We've got y equals -1. That's this horizontal line down here. What else? We've got x equals 0.
0.
And we've got x equals 1. Here is the base. I am not asking the question what happens when you spin the base. We're going to use this, we're going to build the base. So the first thing that you want to look at is, do I know what the base looks like? Okay, great. Second thing, tell me about the cross sections. What are those cross sections? They're perpendicular to x-axis. Can you guys show me perpendicular to the x-axis? Perpendicular to the x-axis, we're slicing this way. There's something else you need to know about your slices. Adriana, what else do you know about the slice?
They're squares.
They are squares. Christian, can you be the square? Okay, so I need a square cross-section perpendicular to the x-axis. So, this way? This way?
No,
Yes.
first way.
No way.
It should be this way, right? Here's your x-axis. My cross-section, I'm like slicing it this way, perpendicular to the x-axis. The squares are coming out of the board at you. We are not even gonna try to draw the three-dimensional object here. But if this is your base, is everybody kind of okay with what this might look like? Right, squares over here, squares over here, squares over here. Squares are getting bigger or smaller? They have to be getting smaller, but they have to be a square all the time. So here's my recommendation for you in terms of drawing. I'm gonna draw our friend, the little representative slice. That little rectangle, right? That slice that we've drawn forever and a day. Here's what I need to know about that slice. I need to know how wide it is. How wide is that?
Change the next.
Right, this is your dx. It is a dx kind of integral because your square is perpendicular. The other important thing I need to know is how long is that slice? I'm just going to call that L. I'm just going to call it L, and I bet some of you know exactly how long L is. How long is L? E to the negative x?
Plus.
Right, minus negative 1 or e to the negative x plus 1, depending on how you want to describe it to me. But you're thinking top minus bottom. Good, it's all the things we've been doing. My slice has a thickness of dx. It has a height of L. What I'm going to do is I'm going to, in my mind, take this little slice and lay it flat. Because I can visualize that. I can even draw that. So, one more time. Go in here, take it, lay it flat. Still have a square. That square has a little thickness. So here's my square slice perpendicular to the x-axis. Abraham, you okay? Okay, lay that square flat. The length of this side right here is what I'm going to call L. Because this is a square, all four sides are congruent, all angles are 90-degree angles. So not only can you tell me how long this piece is, Ron Beer's question earlier, what's the height going to be? If these guys are congruent, if this is L, doesn't this have to be L? Okay? And how thick is the slice? Right, that thickness is this dx. So if I said, hey folks, what's the volume of one slice? These should be familiar questions. We would focus on one slice. How do I find the volume of a slice if it's a square? Length, width, height. L times dx, or if you want, L squared dx. We've got the base, we've got the slice. What we're really after, though, is the solid. To get to the solid, I've got to think not about one slice, but all the slices. If I want to find the volume of a solid, what would Riemann tell us to do? Trust the instinct. Tell somebody near you. What would you do? What would Riemann tell you to do? We've got our base. We've got our slice. We know volume of a slice. Volume of a solid.
Like, make dx minus 1.
Jennifer, what does Riemann tell us to do?
Use an unlimited amount of.
Wait, one more time.
Use an infinite amount.
I want to use an infinite amount of slices, an infinite number of slices. How am I going to add up an infinite number of slices? What's the tool, the calculus tool that you use to add up an infinite number of things? David, what's the thing? Okay, you could use big sigma, but ultimately what winds up happening, right? I mean, you would do like a sum of like L squared dx. You'd say, let me take the limit as n approaches infinity. I'm abusing the notation a little bit here. But when I see this infinite sum, what that really translates into in calculus class, it's the integral. It's the integral. I'm integrating L squared dx. Well, whenever we're integrating, you have to tell me where you're integrating from and where do you stop integrating. Where do we start? You're going to start at 0. You're going to end at 1. So we're going to integrate from 0 to 1. The last thing, if you're going to like go to your calculator and get an answer here, what's L? Right, L is the length of this slice. What I heard from Noemi is it's e to the negative x minus negative 1 or e to the negative x plus 1, right? So what I'm going to type into my calculator, I'm going to say, okay, so the volume of the solid, and just get your calculators out. You're going to integrate from 0 to 1, e to the negative x plus 1 squared dx. Once you get a decimal answer, I'll take some questions. Oh. Okay. You would never tell me 2.69.
Oh, 2.69.
Yeah, you would never tell me 2.69.
Bobby.
Ever, ever, ever. All right, I've seen from a lot of folks 2.696,
Yes.
2.697 maybe, depending on, are you rounding or truncating? How many guys honestly are coming up with 2.696 or 2.697? All right, we're in a good place. Before we move on, what are the questions that are out there? Abraham. Edgar.
So this time we're not, okay, so normally what we would do is like plug in, once we graph or like plug in the equations to the graph,
Yep.
we would just put like bar and like we would get like F1 and F2. But this time we have to come up with a different equation.
You're coming up with a different volume equation because we're not spinning things. In the world of spinning things, you're getting cylinders or you're getting washers. Now I'm telling you differently about the slice. I'm always going to describe the base, and it's worth sketching the base so you get an idea what you're looking at. I'm always going to tell you about the slice. I'm going to tell you, which way is this?
Perpendicular to the x-axis.
Two ways to say it. I heard parallel to the y-axis, and the other way is
Perpendicular to the
perpendicular to the x-axis. But it's the same slice, right? I'm going to slice this way. I'm also going to have to tell you what shape. This guy over here is a square. Not always going to be a square. I'll have to give you the base. I'll have to tell you about the slice. Once I've done that, you need to use like your geometry ideas and a little bit of inspiration from Riemann to get the final answer. Mostly okay?
Okay.
Jennifer.
I have a question, but it's kind of like, not.
Okay.
What if, like, if it was like a hollow base, like, would you do the same thing you did with the body?
I have an answer for you, but it's not for right now. It'll go with the question that's not for right now. All right, let's see what you guys can do. For right now, we are just going to play calculator active for all the things. For all the things. Problem number 2. Take 2 minutes, show me what you can do, we'll talk in a bit.
Just a
35. Yeah.
Okay, Mariah, can I trust you with my lightsaber?
Remember what you did last time?
Edgar.
Oh, can you trust me with the
no.
We'll find out.
Last time Mariah's lightsaber did this.
No, you can grab the slices. Yeah, let me give you something that's less dangerous. I'm just giving Mariah something to keep her awake. It's all about the base, it's all about your slices, and it's all about some calculus. Perpendicular and parallel. Right, you say perpendicular to the x, I say parallel to the y. Those are the same.
I saw something that's two sides.
Oh yeah, and then it makes the triangle.
Right here, you okay? It's on the desk, pulling you down there.
So the x-axis, so it's like the slices are going this way.
Hey, this is a the congruence of the legs.
Okay, from walking around, it seems like everybody's good with the base. Right, x plus y equals 1, I'm going to change it to y equals negative x plus 1, I've got a triangle, great. Jasmine, tell me about the slices.
Perpendicular to the x-axis.
Perpendicular to the x. Can you show me perpendicular to the x? This way, right? This is the slice. Tell me more. There's something else about the slice.
They are right isosceles triangles.
Okay, Edgar, you've got an example of a right isosceles triangle in front of you. Okay? Right isosceles triangle. What's so special about the right isosceles triangle? Two things. Let's get some hands on this. What are the two things? What are the two things? Noemi, what are the two things?
It has two congruent sides,
Two congruent sides. Which ones are they?
the base times height.
I want to be careful. I don't want to call them base and height, the fancy words. If you talk about the right isosceles triangle, you no longer call them base and height. You call them the, begins with an L, legs. They are the legs. This guy here is still your hypotenuse. So right isosceles triangle, the legs are congruent, and this guy over here has to be a right angle. So let's be really specific. Cross sections taken perpendicular to the x-axis are right isosceles triangles with one leg on the base. Right, so I'm slicing, I've got to take a leg and put it on the base, which is very different than if I said put the hypotenuse on the base. Is everybody okay that that's the slice? Two questions I'm going to ask. You know exactly what the two questions are. How wide? How wide is each of these little right isosceles triangles?
Yeah.
How wide? It's, right, if I make my little slice, it's dx wide. How tall?
L.
For now, I'm just going to call it L. That's fine. Now let's go over here and take a look at the geometry of my slice. I've got a right isosceles triangle. Boom. Those are congruent. I've got to draw a little bit of thickness, so I just make it a little bit thick. This side here is L. This thickness over here is your dx. This side over here, also going to be called L. My question for y'all, and I think this is worth having a quick conversation with your neighbor. What's the volume of one slice? How would you find the volume of that one slice?
1 minus x squared.
Not 1/3 base times height. Nope. You are so close, David, but it's not 1/3 base times height.
It's 1/2.
1/2 base.
All right, I've heard it from enough folks now. 1/2 base times height. But that, for those of you that are like, oh yeah, that's it. No, that's not it. 1/2 base times height is not volume. This is area. If I want to get to volume, I need to then multiply by the thickness of this, right? It's a triangle with some thickness. But I'm not using B and H. It's 1/2 of L dx. Of course, if you want to make it prettier, 1/2 L squared dx. You start with the base, you focus in on the slice, but the slice isn't what you're really after. What you want to know is what's the volume of the object, right? What's the volume of that solid? And it's getting here to the volume of the solid that you say, gosh, what would Riemann tell me to do?
The integral.
You're going to do an integral. Uh-oh. I'm going to do an integral. I need to know what I am integrating and what are my limits of integration. Right, we're going to go from 0, because that's one of my boundaries over here. Where do I end?
One,
Why 1, Robert?
because that's what it intersects on the y.
Good, but not the y-axis, the x, right? This is the point 1, 0. So I'm gonna integrate from x equals 0 to x equals 1. My integrand is this 1/2 L squared dx. But be careful, you need to be able to tell me exactly what L is. How long is L in terms of x? Right, you're going from the line all the way down to the x-axis, so L is just negative x plus 1. So this is the integral from 0 to 1, 1/2, negative x plus 1, the whole thing squared, dx. For now, feel free to type that into your calculator. Make sure you're getting the right number answer. Over the next day or two, we'll take away the calculator.
Mr. D.
Yeah.
Why is it plus 2?
Why is it or isn't it plus 2?
Isn't the graph itself x plus 1?
Can we put the one
X
outside?
plus 1.
Like the graph itself, isn't it negative x plus 1?
This is the line x plus y equals 1, so you subtract x to the other side to get negative x plus 1?
Well, aren't you supposed to subtract 1?
No, I'm going down to the x-axis.
Oh, so 0. Yeah.
Right, which is y equals 0. If it had been lower, then you'd have to do a little bit more. Jasmine, what are you getting for a number? You what?
1667.
0.166. Anybody else? 0.1667? Okay. Really today, I just want to focus on like the geometry of the base, the slice, get over to the solid. Tomorrow, we're going to take away the calculator, so we're getting to focus on the new calculus skills. All right, some of you guys can do the third one. Who are they, Edgar? Why am I growing your brain? Because I care. All right, I'm seeing some not so good stuff happening. Base. So if I can get you guys to stop just for a second, because I'm not seeing many folks that have a good base here. Okay. And I think what the problem is that we don't remember enough about the equation of a circle. Okay? In general, all circles have the form x minus h squared plus y minus k squared equals r squared. That's from like geometry, that's something that you know from pre-calculus maybe. This is just a pre-calculus fact. I was there when Mr. S taught it. Every circle has this form, where the h and the k is the center, and the radius is r. So if this is true, if this is not a lie, what do we know about the circle? 2 people? 3 people? 4 people? Noemi, what do you know about the circle? It's a full circle. Give me more about that circle. Could you tell me either the center or the radius?
The radius is 2.
The radius is 2. Rambir, do you know the center?
0, 0.
The center is at 0, 0. So let's draw the base. Here's my base. Draw a circle with the radius of 2. Here's my center. I'm going 2 in all the directions. That's the base. Questions about the base? Now, what I saw some people said, okay, well, if x squared plus y squared is equal to 4, then that means that y squared equals 4 minus x squared. True, that's good. They then went on and they said, okay, y equals the square root of 4 minus x squared, and there's a mistake that they're making here already. Plus or minus. Then the lethal mistake. A lot of folks saying, well, the square root of 4 is 2, and the square root of x squared is x, but that's not something that you can do when it comes to addition and subtraction. So this is the lie. Okay? The top half of the circle is the equation y equals square root of 4 minus x squared. That's true. The bottom half of the circle is the equation y equals negative the square root of 4 minus x squared. That's true. All right, from there, keep going. Oh, was that? Okay, that was back in the day when you thought you had this. Daisy, what do you know about those slices?
They're gonna be rectangles.
They're going to be rectangles. So I've got my rectangle. David, what's the other thing we know about these slices?
They are
We've got rectangles. What else are we reading about these rectangles? Parallel to the x-axis. Which way? This way. What else do you know, David? Or Eunice, what else do you know? The height. So if this is my rectangle, everybody's okay with what the rectangle is going to look like? Whatever that length is, what's the height?
4 times that.
It has to come out of the board 4 times as much. So let me just draw in L real quick here. Okay. So here's L. Don't try that at home. So there's the rectangle, has a length of L. It comes out of the board 4 times as much, and what I'm going to do is I'm going to lay it flat just so I can visualize this. So here's my rectangle that has a length of L. How tall?
4 times that.
4 times that, so there's 4L. And it's got some thickness. Think about this before you answer the question. Tell somebody near you, what's the thickness? Don't tell me, tell your neighbor, what's the thickness? What's the thickness of this rectangle? Parallel to the x-axis. How many guys going for dx? How many guys going for dy? Okay, that seems pretty unanimous. Are we feeling it about the dx dy? Right, if your slices are this way, if they're horizontal, it's dy. Great. So here's dy. Easy question. What's the volume of a slice? For this particular slice,
Base times width times height.
base times the height times the width. So L times 4L times, not y, dy, my bad. So 4L squared dy even better. Okay, see what you can do from here. I hope everybody avoids the lethal mistake.
From there to the shape of 4L squared.
Hearing the conversation happening in some of the
Negative
groups.
2 to 2 of 4
Oh,
squared
painful.
square. dy. I don't know what equation it is. Either that one or that one. Oh, I plug that in for L, right? Subtracted.
Yeah, so we already percentage.
Oh, don't we have to add these? Because you know how one of them is negative and one is positive? We're only finding, they're going to be positive, we're only finding the top part.
Minus 4x squared.
Oh, and then you need to solve it. Because it'll just be 4 minus x squared.
All right, if I can pull everybody together, we've got about 3 minutes left. The conversations that are happening at the groups are awesome. A lot of folks are starting off with something like this, and that's a good idea. We draw the base, you focus on the slice so that you eventually get to the solid. Lots of conversations happening over here about what is L. Go back to the diagram. Here's L. What do we know about L?
1, 4, 8.
L goes from this side of the circle over to this side of the circle. A couple of the groups have figured out that the key is this is a dy integral. If you're going to work with a dy integral, then you need to be able to talk not about top minus bottom, by right minus left. If I'm in a right minus left world, then everything has to be in terms of y. So don't tell me x squared plus y squared equals 4. That doesn't do me any good. I need to get this in terms of y. So we're going to solve this for x, because you want it in terms of y. If x squared equals 4 minus y squared, well then what is x really? Square root of 4 minus y squared. Hold on, though, I'm hearing the mistake happen again. It's plus or minus. The positive is the right half of the circle. X is the square root of 4 minus y squared. The negative is the left side of the circle. So it's negative square root of 4 minus y squared. L is square root of 4 minus y squared minus the negative of the square root of 4 minus y squared. I'm going from right to left. Square root of 4 minus y squared minus a negative square root of 4 minus y squared. A better way to say this is going to be plus. A better way to say square root of 4 minus y squared plus square root of 4 minus y squared. Square root of 4 minus y squared plus another square root of 4 minus y squared is 2. Stay with me just for 1 second. All we need to do is wrap it up. Okay, your volume over here, it's going to be an integral of 4 times what's L? It's 2 square root 4 minus y squared squared dy. Last thing I need to really wrap this question up, limits of integration. From where to where?
Oh, wait. It's -2.
Negative 2 to 2?
No, it's -2.
Right, not negative 2 to 2, negative 2 to 2. I know you guys, you just said the same thing. The issue is the hand motion. Am I going from x equals -2 to x equals +2? No, I'm going from y equals -2 to y equals +2. Okay, Dennis, before anybody totally freaks out, this is definitely some big brain stuff, but we're off to a great start. Tonight's homework, you guys picked up on the way in,